Hi, in today's class we will discuss about voltage and current equations of the transmission line. In last class we discussed about the parameters of the transmission line. In that we discussed only primary parameters. What are they? R, L, C, G. Okay. Now we will discuss about voltage and current equations of transmission line. Voltage and current equations on transmission line or else off transmission line. Let us consider a transmission line of length x equal to L. Let us consider a transmission line of length x equal to L. We want to determine the voltage and current on the line, means we need to determine V of x and I of x. V of x comma I of x. This gives voltage and current on the line. For that, we can derive these voltage and current equations in the primary parameters of the transmission line, means V of x comma I of x are functions of primary parameters R, L, C and G. These are functions of R, L, C, G. Now we will see how we can derive voltage and current equations. We learned that this R, L are series elements. R, L are series elements. From this we can write series impedance Z equal to R plus J omega L. Z equal to R plus J omega L. Similarly, what are the parallel elements? C and G are the parallel elements, that is parallel admittance, that is Y equal to, here duality of R is G and duality of L is C, that is G plus J omega C. Parallel elements are C and G, that's why G, C, R plus J omega L. Now we can write voltage as what? V equal to I into Z. And similarly, I can be written as what? V by Z or else V into Y, that is V into Y. In this way we can derive, what? Voltage and current equations. Now we can write, assume voltage is constant and current is varying. Here let us take a point A and a point B. Let us assume the distance between point A and B is equal to dx. That means let us divide this one into equal parts. Let us divide this transmission line into equal parts. Each one is having a length of dx. For that, let us take this starting point as A and this one is B, this one is B dash and this one is A dash. That means like this. Here this is A and this one is B, this one is B dash, this one is A dash. Let us assume voltage at this place as V and current at point A is I. Similarly, at point B, obviously when signal is passing from one place to another place, its strength is degraded because of attenuation. That's why I am taking at point B voltage as V minus dV. That means this much of voltage decreased by dV. And similarly, current is I minus dI. That means the current difference between point A and point B is dI. So here it is I and this one is I minus di. Now let us write voltage difference between points A and B is points A and B. What is the voltage at point A? V. What is the voltage at the point B? V minus dV. And this difference is per what? The distance between A and B is what? Dx. So that's why this difference is per unit distance. That's why voltage difference per unit distance is like this. And we know that as there is a difference in the voltage generally different in case of the series elements. In series, current is same. That's why let us write, as current is constant or current is same, let us write this voltage in terms of the current. We know that V equal to what? I into Z. What is Z? Z can be written as what? R plus J omega L. Let us simplify this one. Let us simplify this one. We can have what? That is v minus v gets cancelled. Minus of minus plus, that gives dv by dx is equal to I into r plus j omega L. Let us take this as equation 1. Similarly, let us write current difference between point A and point B. Current difference between point A and B is given by I. Point A current is I, at point B current is what? I minus di. As it is difference, we have to take minus, and this difference is for what? Unit distance dx. In this way you can write. Here we are taking current difference means what? Current is different. Generally current is different in case of the parallel elements. What are the parallel elements? G and C are the parallel elements. R, L are series elements. C and G are parallel elements. This one is C and G are L. So this part, equivalent part of this one is like this. So that's why we can write this one in terms of the parallel elements C and G. In case of the parallel elements, V, that means voltage is constant. V into Y. What is Y? That is G plus j omega C. Omega is the angular frequency. Now let us simplify this one. I minus I gets cancelled. Minus of minus plus. Then you have what? Di by dx is equivalent to V into G plus j omega C. This one is equation number 2. Now if you see equation 1 and equation 2, these are the voltage and current equations that are nothing but what? First order differential equations. We can easily determine the solution for the second order differential equation, homogeneous second order differential equations. So we can change this 1 and 2 into second order homogeneous differential equation by differentiating equation 1 and equation 2 with respect to x. Let us first differentiate equation 1 with respect to x, then differentiate equation 2 with respect to x, and we will have what? Second order differential equation. Now differentiate equation 1 with respect to x. On left hand side, what you will get? dv by dx, differentiation of dv by dx with respect to x gives what? d square v by dx square. And we know R, L, C, G are constants. Primary parameters are primary constants because they are uniformly distributed throughout the length of the line. That means they are not changing with respect to x. Only change in what? Voltage and current. V becomes V minus dV and I becomes I minus di in this case. So that means there is a change in voltage and current. There is no change in R, L, C, G. So that's why here differentiation of this one on left hand side d square v by dx square. The change in I with respect to x can be written as di by dx, and r plus j omega L, it is a constant. R plus j omega L is a constant. Similarly, G plus j omega C is also constant with respect to x. Here we have what? Let us substitute di by dx. According to equation 2, di by dx is what? V into G plus j omega C. So that's why here we can write r plus j omega L as it is, this one. And what about the di by dx? G plus j omega C into V. I am writing G plus j omega C into V. Now if you see this one, it is what? Second order differential equation. On left hand side, what we want to get? That is d square V by dx square. And if you see this one is what? Constant. R is constant, L is constant at the given frequency omega. That means at F, omega is also constant. This one is constant. Similarly, G is constant, C is constant at the given frequency. G plus j omega C is also constant. That means constant into constant gives what? Some constant square. I am writing that one as some constant. As signal is propagating, we can take propagation constant in this case. Constant into constant, that is constant square. In this case, I had taken this one as what? Propagation constant square into V. Now we have d square V by dx square equal to gamma square v. This is equation number 3. This is equation number 3. Similarly, if you differentiate equation 2 with respect to x, differentiate equation 2 with respect to x, what we will get? On left hand side, d square I by dx square is equivalent to g plus j omega c, that is constant, because g and c are not varied with respect to distance, but there is a change in voltage, that is change in voltage with respect to x can be written as dv by dx, change in voltage due to change in x. Now substitute that dv by dx from equation 1. Substitute equation 1 in above equation. We will get another equation, that is on left hand side you have d square I by dx square is equal to g plus j omega c dv by dx. What is dv by dx? I into r plus j omega l. Already here you have g plus j omega c, here I into r plus j omega l. We can write that as what? R plus j omega l into g plus j omega c, g plus j omega c into I. Since according to equation 1, dv by dx is what? I into r plus j omega l. Already here you have g plus j omega c. Here if you see this one, this is d square I by dx square. This one is constant, this one is also constant, constant into constant, constant square, that can be written as gamma square into I. Here in both the cases we have taken gamma square as what? R plus j omega l into g plus j omega c, where gamma equal to r plus j omega l into g plus j omega c. Let us take this as equation number 4. We have equation 3 and equation 4. If you see equation 3 and equation 4, they are what? Homogeneous second order differential equations in the form of what? In the form of what? Like this, d square y by dx square is equal to some constant square, that is k square. Here instead of I and instead of v I am taking as y, k square y. That means equations 3 and 4 are in the form of second order, homogeneous second order differential equation, d square y by dx square equal to k square y. The solution of this one is nothing but what? Y equal to some c1, that is constant. I am taking that constant as y naught into e to the power minus kx. I am taking y1 as y naught or else c1 as y naught plus, and next one is second constant, that is c2, that can be taken as y naught minus e to the power kx. So therefore the solutions of equation 3 and equation 4 can be written as, the solution of equation 3 is v of x, here we can write this as y of x, v of x equal to, instead of y naught plus, here v naught plus e to the power minus gamma x, and second one, that is v naught minus e to the power gamma x. Similarly, the solution for the equation 4, as it is second order differential equation, instead of y, here you have I. Y of x can be written as what? I of x. It has a forward wave, so that is I naught plus e to the power minus gamma x plus reflected wave, that is I naught minus e to the power gamma x. So this is voltage equation on a transmission line, and this one is current equation on a transmission line. So combinedly these are nothing but what? Voltage and current equations on the transmission line. In this video we derived what? Voltage and current equations. To derive that, what we have done, we consider a transmission line of length x equal to L and consider points A and B. At point A we assumed voltage as V and current as I, and at point B we have current as what? I minus di and voltage as what? V minus dV. That dV and di indicates what? Difference in the voltage and current. And the difference between voltage and current at point A and B is taken, and we have written dV by dx equation, that is what? I into r plus j omega L. We got like this, and after this we derived current difference equation per unit length, that is di by dx, that can be equivalent to what? V into g plus j omega c. And if you differentiate these two equations, we got equation number 3 and 4, that is d square v by dx square, that equal to gamma square v, and d square I by dx square equal to gamma square I, where gamma equal to, actually it is, sorry, under root r plus j omega l into g plus j omega c. Without root, that is gamma square equal to r plus j omega l into g plus j omega c. So if you see summary of this derivation, we have total of 6 equation. First one is what? Difference equation dv by dx. Next, difference in current equation di by dx. Next, second order equations d square v by dx square, d square I by dx square, and last one is v of x, I of x. Let us see this one. Voltage is different, that means current is same. Current is same in series elements. What are the series elements? R and L, that is series impedance R plus j omega L. And here current difference means current is different, means voltage is same, assume. Then voltage is same in parallel elements. What are the parallel? G and C, G plus j omega C. And next here, if you differentiate this one with respect to x, we got this one as what? Gamma square into V, and this one as what? Gamma square into I. The solution of these two is nothing but V of x is nothing but V naught plus e to the power minus gamma x, V naught minus e to the power gamma x. I of x is what? I naught plus e to the power minus gamma x, and I naught minus e to the power gamma x. Why we are getting these two terms? One is forward and another one is reflected. Means when signal is propagating, as there is no reflection, we have only forward wave, this one only. If there exists a reflection, then we will get this reflected wave also. So that's why the solution is what? Sum of forward wave and reflected wave. So this is about what? Voltage and current equations on transmission line, or else voltage and current equations of the transmission line. In next class we will discuss about one of the important parameter, that is secondary parameter, characteristic impedance. Here we derived gamma as what? Under root r plus j omega l into g plus j omega c. This parameter is derived parameter from the primary, so that's why gamma is known as one of the secondary parameter. In addition to this secondary parameter, we have another parameter, that is z naught. In the next class we will discuss about this characteristic impedance. Thank you.